All right, to solve absolute value equations and inequalities, you write two equations or inequalities. Let me give you an example. So here's the equation, 3x minus 1 equals 7. So to solve this absolute value equation, I'm going to write two equations. One looks just like the first, except that I took the absolute value signs off. And the other, the only change I make is I make the 7 negative. So whatever is on the other side of the equal sign from the absolute value, you make negative. Now I solve both of those. I get 3x equals 8. Divide both sides by 3. X equals 8/3. When I solve this one, I get 3x equals negative 6. X equals negative 2. So I get two answers, this and this. And if I graph them on the number line, here's 0, here's negative 2, here's negative 1, 1, 2. 8/3 is going to be between 2 and 3. So this might be 8/3. All right? And you're basically just graphing the two numbers that you got for solutions. They're just those 2 points. All right? Now, to solve an absolute value inequality, there's a little bit more to it. Still going to write two statements. All right? I'm going to put two different ones up here. Let's say this is x plus 5 is less than 1. And let's say we have another one that is 2x minus 3 is, we'll make this one greater than or equal to 4. All right, when I write my two statements, okay, then x plus 5 is less than 1. Of course, my first statement, I take the absolute value signs off. X plus 5 is greater than negative 1. Not only do I make this number negative now, all right, but I also flip the inequality sign. So you have two things to do, but there's one more thing that's very important. A less than, when used with an absolute value, means and. So I have to write the word and between my two statements. That's critical, all right? Now when I solve this, I'm going to subtract 5 from both sides. X is less than negative 4, and over here, x is greater than negative 6. Now, an and statement can be written all as one if you like, all right? But you don't have to. You don't have to. You can leave it just like that. But if you want to write it all as one, you can say negative 4, put a less than sign, put an x, put another less than sign, and, negative 6, put a less than sign, put your x, another less than sign, and put your negative 4. All right? This says x is less than negative 4. There's your x is less than negative 4. And x is greater than negative 6. X is greater than negative 6. You see, there it is. All right? When I graph that, then there's negative 6, negative 4. Now, less than has an open circle, and I'm going to show you everything in between. So here's what the graph of that inequality looks like. So you can either write it like that, or you can write it like that. Remember, only ands can be written in one statement like this. All right, well, let's come over and compare what we just did to what we're going to do right here. We're going to write two statements. 2x minus 3 is greater than or equal to 4. My first one looks just like the original. The second one, remember that I flip the inequality sign and I make the number negative. All right, but a greater than is an or. A greater than, when used with an absolute value, is an or, and I have to put the word or between them. All right, so when I solve these, then I get 2x is greater than or equal to 7, or x is greater than or equal to 7/2. Or, and over here, add 3 to both sides. I get 2x is less than or equal to negative 1, or x is greater than or equal to 7, or x is less than or equal to negative 1/2. It's an or. You cannot write an or in one statement like you can an and. So if I graph this, then I have something that looks like this. Negative 1/2, 7/2, all right? X is greater than or equal to 7/2, well, that's this part of the number line. X is less than or equal to negative 1/2, and that's these numbers over here. And sure enough, you know, that's what an or graph with an absolute value looks like. Now, let's suppose that we want to go backward. We have the inequalities, we know how to solve them, but let's suppose we've got to write an absolute value statement from a graph. All right, so here's my graph. We'll make it from about negative 11 to negative 1. And we'll shade everything in between. Now, if I were writing a compound inequality to represent this graph, then I would simply say that it is x is greater than or equal to negative 11 and less than or equal to negative 1. That's a compound inequality. But I don't want a compound inequality. I want an absolute value inequality. Well, an absolute value inequality will express the same thing in a different way. First of all, I want to tell how far away I am on either end from the middle of this graph. All right? So, an absolute value is a distance. All right? I'm actually going to scoot this over. It's a distance. So, an absolute value is, all right, these are my choices right here for is, a distance. Well, it's, okay. It's a distance from what? Well, it's a distance. Where am I? How far away am I from the middle number? So it's the distance from the middle number to either end. All right? So this right here must be where my middle number goes. Middle of the graph. All right, to get a middle number, to get the middle of two things, you add and divide by 2. You take an average, all right? So negative 11 minus 1 over 2. I'm adding negative 11 and negative 1, and I'm dividing by 2. That's negative 12 over 2, which is negative 6. So my middle number is negative 6. All right, well, how far is it from negative 6 to negative 1? No, it's 5 units. Just like it's 5 units on this end. All right, so my absolute value inequality for this will be x minus negative 6, the absolute value of x minus negative 6. Now I have to pick a sign here. Well, remember, this is an and. All and graphs look like this. All absolute value and graphs look like this. They're shaded between two numbers. So an and is a less than. So I pick my less than. Now since the n numbers have closed circles, it's going to be less than or equal to. And then the distance from the middle to either end is 5. So this says the distance from my number to negative 6 can be no more than 5. All right? Now we would just clean this up and make it x plus 6 less than or equal to 5. Let's do one more. Now I'll leave my explanation up here. Let's suppose that we are doing an absolute value inequality for this graph. All right? And we'll say that these numbers right here are negative 1 and 7. Okay? Now, I want to write the absolute value expression for this graph. All right, well, this is an OR graph. So I've got x minus, and OR is a greater than. Now, I don't need an equal sign with that because those are open circles. all right? So all I need to do now is figure out what's the middle of my graph. That's where the middle number goes. And then how far away is each end from that middle number? So the middle number of my graph is the average of 7 and -1. So -1 plus 7 over 2. Well, that's 6 over 2, which is 3. That's the middle of my graph. So x minus 3. And then the distance from 3 to 7 is 4, just like the distance from -1 to 3 is 4. So that's the number that goes here. So the absolute value expression for this graph is the absolute value of x minus 3 is greater than 4. This means that my number, the distance from my number to 3 is at least 4. Well, no, it's more than 4. It's more than 4. At least would include 4. So the distance from my number to 3 is more than 4. All right? So you would see this in a situation where you had, say, the length of something. You know, the length of a piece of rope has to be 2 feet, give or take an inch. All right? How would we write that as an absolute value? Well, we would say the absolute value of x minus 2. 2 feet. All right? X minus 2. So my rope length, the difference between my rope length and 2 can be no more than 1 inch. Now 1 inch is not the same units as 2 feet, so if I want to write it as feet, I would say 1/12. All right? Or I could change the 2 and I could say the absolute value of x minus 24 inches is less than or equal to 1. I can either put all of it in inches or all of it in feet. This is how you would express this in absolute value form.